In this video, we're actually going to go through some lab exercises here and construct some more circuits. So we've already done this first part here where we've set up the breadboard with our 9-volt battery by kind of plugging in the positive terminal as signaled by the red wire to the red rail, and the black wire is signaled by that to the negative rail there. So if I flip over to the camera here, you should be able to see we have this right here, and then here's our battery. But I am keeping it disconnected for now because remember, we want to kind of leave things disconnected until we've double checked our circuit here. So flipping back, our first exercise is something we already did here, right? So we just wanted to turn on an LED. And so for this, we'll need a 1 kilo ohm resistor and an LED of our choosing. Remember, there's a bunch of different colors here, so you can use whatever you want. So I have like a blue one here. I also have a green one. And one important thing to note is that the little plastic cover is not what makes it that color. These plastic covers are just colored to indicate to us like what color of light it will emit. It's the specific chemical properties in here that make it emit a specific spectrum of light. But it's just colored so that when we're sorting through a bin of a bunch of different LEDs, we know what's going on. So like this one right here is entirely clear. It's slightly different shaped, but I know that it's blue because I just plugged it in. So we'll plug this one in and I'll kind of show what I'm talking about here. So we're going to take our 1 kilo ohm resistor, and so these have kind of come out of a bin that I've had a mess of, so the legs are splayed everywhere. So I'm going to try and tighten it up here, which might be, you know, a helpful exercise to do for yourself. And then just kind of make sure that they're nice and plugged into the sockets here. The way these sockets work is they're little springs that are clamped together, and you're just trying to insert that in between the springs there. And so I'm going again from the positive to somewhere over here, and then I'm going to take this one here and I'm going to take the longer of the legs, which again is positive, so it's going to go to the resistor, and the shorter leg is going to go to the minus, which is the return path for the battery, kind of completing the circuit here. So if I plug this in, we should see, look at that, a blue light here. And again, it's not because of the color of the plastic, because here it's clear, it's just due to the chemistry going on inside of there. So that's kind of our first exercise here. So I'm going to go ahead and unplug the battery now. And let's take a look at our second one here. So if I scroll on down, what do we got? So here what we're going to do is we're going to play with something called a photoresistor. So we've just been using resistors, which provide some constant resistance. In the last case, we were using a 1 kilo ohm resistor or 1000 ohm resistor. So what we're going to do is we're going to use a photoresistor, which is a part that changes its resistance based on the intensity of light it's exposed to. And so as the intensity of the light increases, we'll see that the resistance will decrease. And so if I grab it here, this is what it looks like. It's got some longer legs, it's got a little orange head and some silver plates here, and it will change its conductivity or its resistance based on the light. Alright, so what we're going to do is we're going to try to turn on the LED and vary its intensity using this. So all we're going to do is we're going to swap out this 1 kilo ohm resistor with this photoresistor here. And because this has longer legs, we want to make sure that it's not touching, you know, certain things that we don't want it to touch, and make sure that it's all the way in. And I think it is, so let's see what we got here. So you can see when I plug in the battery, it's on, but it's very, very dim here. So actually, let me grab a little flashlight here. And so if I, you know, expose it to a brighter light here, this little headlamp that I have, let me see. So it's dim, and then let me point it this way here. Oh, I'm trying not to wash out the light. Yeah, there you go. You can kind of see what's going on. So as I move it closer, that light gets brighter there. Awesome. All right, so now for our next one here, we're going to play with something called a thermistor, which is, you know, similar in that it's a part that varies its resistance, but instead of doing it based on light intensity, it's now doing it based on the temperature. And so we'll flip back over here, and I'm going to take this out of the circuit, and I'm going to use the thermistor here, and this is what mine looks like. This is an NTC, a negative temperature coefficient thermistor. It has a small little black bead here, and all I'm going to do is plug it right back into the circuit where I had it, so that, you know, the current flows out of the battery into the positive terminal here, then through the thermistor, and then into this rail, and then through the rail, through the LED, back to the negative, and it goes back to the battery where it then, you know, emits back a positive voltage. And so if I plug this in, we see, all right, it's glowing. If I hold it, we're not going to see really any change, even though I'm slightly heating this up with my body heat. It needs a pretty drastic temperature change in order for it to change the resistance, because these are used for very, very wide temperature swings and being able to detect, you know, very, very cold temperatures and very, very hot temperatures. And so I'm going to use this lighter here, and we'll see that it starts to glow brighter and brighter and brighter as I, you know, put some flames on this, and then it decreased its brightness over time again. So there we go, one more time, and then it goes back down. And I know the lens is kind of doing a little bit of autofocusing here. Oh, and look, I actually burned out this. So what happened there is I made the resistance go so low due to the heat that too much current went through this LED, and now it's no longer usable. I have fried this part. And so if we look inside of there, it's really hard to see. Let me see if I can get it to autofocus. You can see there's a little bit of black in there. Yeah. And so that black now that's right there between those two conductive plates, that's the semiconductor material, that little bit of black is indicating to me that this part is no longer good. So I'm gonna have to throw it away, and we'll get another one for our next exercise here. So let me just, you know, for the sake of this, make sure my circuit still works. And yeah, that works fine now with this green LED. All right, so now for our next one, what we're gonna do is we're going to use something called a potentiometer as a dimmer switch. And again, this is something else that varies its resistance, but it's doing it based on us turning a little dial. And so we're gonna turn a dial that is connected to a wiper, and that's gonna move along this resistive material. So this is a 3-terminal part, meaning that it has 3 different pins here. So between these outermost pins, there is some constant resistance, and I think for the one that I have here, it is a 10 kilo ohm resistance between those parts. And then as this wiper kind of scrolls along this here, it's changing the resistance between these 2 pins and these 2 pins so that it's some proportion of that total resistance. So like if it were straight up and down, there would be like 5 kilo ohms between these 2 and 5 kilo ohms between this 2. But because it's a little bit more to the left, there's slightly less resistance on the left and more on the right. So we could think this might be like 4 kilo ohms and this could be 6 kilo ohms. And so what we're going to do is we're going to wire it up in the circuit kind of as shown here and as shown here, where we're only going to use 2 of the terminals, but we're going to have our like positive 9 volts going to, again, still a 1 kilo ohm resistor, but then we're going to have it go to the middle pin here and go on down to here. And the reason why we still want this resistor in the circuit is if I just wired it directly to here, and if I scrolled this all the way over to one side, we could theoretically have very, very low resistance, like close to 0 ohms of resistance, which would mean that our LED would be getting the full 9 volts from the battery, which again would fry the part. So we want to avoid that. So we're having our 1 kilo ohm resistor here, and then we're just introducing slightly more resistance as we are turning this dial here to dim it. So let's flip back here. And so I'm gonna unplug this so that I can redo some of this stuff here. So we're gonna take the 1 kilo ohm resistor and I'm gonna plug it in here. And I'm gonna remove this LED for a second. All right, so there. And then this is the potentiometer I'm gonna use. They kind of come in a few different forms. So that's what one of them looks like. This is another one here. And so as you can see, this one has like 2 pins on one side and 1 pin on the other side. These are the outer 2 pins, and this is the wiper pin. Here, there's just kind of 3 in a row, so these 2 are the outer, and that middle one is the wiper. And so I'm going to use this one here, and what I'm going to do is I'm going to plug it right here, and it's spaced just perfectly to fit in the breadboard here. And so what I want to do is not use the outer pin, one of the outer pins. I'm going to use the middle pin and then the other outer pin. So I'm plugging the middle pin into the same row as this resistor so that it's the current will flow through the resistor, then into the middle pin, then out through the other pin. And so then what I'll do is I'll put this LED on the row just below that resistor so that it's coming out of the outer pin of my potentiometer. And then I'm plugging the shorter end of the LED, which remember is the negative end, into the negative rail, which goes back to our battery. So now let's turn this on. And so we can see it's kind of dim. So as I turn it to the right, it's getting brighter and brighter and brighter. And then it's all the way to the right, which would mean that theoretically there is like 0 resistance between these 2 points here. And then as I turn it back to the left, it's introducing more and more and more resistance till it gets up close to its maximum resistance. So it's very dim. And so here we kind of have a dimmer switch for our LED. Alright, so let's see. The next one that we're going to do is we're going to use a push button switch. This is also known as a momentary or tactile switch because it is only connected while you're actively pressing it. And so the way that these things work is there are 4 pins on it, and it's made to go just across this gutter here. I kind of mentioned that this gutter is spaced very intentionally for a lot of different parts. One of those parts here is a push button. And so that the way that it works is the top 2 pins are always connected together internally, and the bottom 2 pins are always connected together internally. And then when I press the button here, what happens is it connects the top 2 pins to the bottom 2 pins here. All right, and so what I'm gonna wanna do is introduce this into our kind of circuit that we've built here to only turn on the light when this button is pressed. And so this is what that circuit would look like. So we have our 9 volts going to our resistor, and I could introduce this switch anywhere in the circuit. This is just where it made sense to me to do it. But again, like if we have an open or some disconnect anywhere in our circuit, the current isn't gonna flow and our LED isn't gonna be on. So I could put this anywhere, but I'm just gonna put it here. So 9 volts to our resistor to our switch, and then we go to the other leg of the switch and connect that to the LED, and then go back to the negative end of the battery here. So let's flip over to my camera view here. And so yeah, I'm gonna pop this guy out, and I'm gonna remove the LED. And then what I'm gonna do is I'm gonna grab one of these little push buttons here, and hopefully the legs aren't bent out of whack. There we go. So yeah, it goes just across, and what you can see is I'm plugging the top row in to right where this resistor is. And so remember, the top 2 pins are connected together internally, and the bottom 2 pins are connected together internally. So if I were to plug this into the same as the top row, it would always be on. So what I want to do is I want to plug this into the bottom row and then plug the other end into ground. There we go. All right, and so let me do this. And now it's not on, even though I just plugged in the battery. But when I press this, we can see it's on while this button is pressed. Awesome. All right. So I think for one of the last things we're going to do here, we're going to take a look at an RGB LED. And this is specifically something called a common cathode RGB. And what that means is that there are essentially three different LEDs inside of here. There's a red, a green, and a blue, and they all share a common cathode, or something that we will tie to the negative end. And so in order to turn on each of them, they each have their own kind of positive leg. So if I connect red to power, the red will be on. If I connect green to power, the green will be on. If I connect blue to power, the blue will be on. And I can have all of them on at the same time, all of them off, or any combination in between. And so that's what we're going to do. We're going to try to hook this up along with some switches to independently control each one there. And so in order to do that, we are going to need a resistor for each different color of it, and then we'll connect the other leg to ground. So we're going to need 3 1 kilo ohm resistors, 3 switches, and then our RGB LED. And so one important thing to note is that if you look here, the longest leg is actually negative now in this case, and then the one to the left of that is the red, and then the one to the right of it is green, and then the one on the far right is blue. And so that is going to be our orientation here. So we're going to try to wire this up appropriately. So let's flip back here, and I already have my 1 kilo ohm resistor with 1 switch. So let's just kind of go down the line and do a few more here. So here's another switch, And we'll put a 1 kilo ohm resistor going to the top row there, because we kind of want to standardize on the way that we're building this so that it makes sense. And then I'm gonna do, let's see, we got one more switch here, and I'll go down to here. There we go, so that's in there nice and snug. And then another 1 kilo ohm resistor going from positive to the top of the button. There we go. All right, and then we got our RGB LED with all 4 of the legs there. So you can see that longest one is negative, and then the one on top is red, and then it goes green and then blue. And so I'm not gonna splay these legs out all over the place. I'm gonna put it down here, and then this is where I'm gonna start to use jumper wires. All right, so I'm gonna put this right here, and the longest leg is the second from the top here. So I'm going to mark that by using this black wire here and going from the row that the longest leg is plugged into back to my minus over here. Right, and I could just as easily have done it over here. This is just how I approached it, because what happens is it connects, again, the top row of the switch to the bottom row of the switch. So if I take a jumper wire and I go from, you know, the bottom row to this leg, it's now connected. So if we remember here, yeah, the top is the red, and so I have a red wire. I'm going to try and, you know, indicate what's going on here. So I'm going to go from the bottom row of this switch down to that top leg of the RGB LED, which is the red color. And then I have a green wire here, so I'm going to go from this switch here to the third one down, because it's red, negative, and then green. And then the bottom one is blue, and I guess I don't have a blue wire here, but I'm going to use orange to kind of indicate that it's different from the other ones. And I'll turn that on. So as you can see, I only have a few wires here, but I'm already getting a little spaghetti. This red one was a little long, but that's what we got. Let's see if I turn on this light. Is that any better? Slightly. All right. No, now that's worse. Okay, that's what we got. So let's go through and plug in our battery here and then make sure that it works. So if I press the red one, oh look, we got a red light, green light, and blue light. And then I can do a little bit of color mixing here. So if I hit red and blue, you can see we get like a purple, although it's showing up a little white there. If I get red and red and green, we get like a little yellow there. If I do green and blue, we get like a tealish color, although it's still showing up blue, but you can see like as I press that green, it gets a little more teal. And if I press all 3, I get white. But if I just press these 2, it's purple, white, purple, white. So I know it's washing out the color a little bit because it's a brighter light here on this camera. But yeah, there we go. We have kind of color mixing with our RGB LED. So for the last one, what I invite you to do is kind of make something of your own here. So design a circuit using, you know, some combination of, you know, potentiometers, maybe a photoresistor, maybe a thermistor, maybe, you know, 3 different potentiometers here for each of the different legs of the RGB to really dial in different colors to mix and see how many different colors you can make.